Hi everyone. In the previous classes, we have seen how to construct the circuits for code converters, right? That is BCD to XS3 code converter and XS3 to BCD code converter. Now in this class, we'll see one of the combination circuit, that is comparators, right? Comparators means like basically if you are going to get uh, two numbers like decimal numbers, if you observe 5 and 6, if I ask the question which one is bigger, right, I can able to define, right? First, 5 is greater than 6, no. Is 5 is less than 6, yes. So I can say that 6 is bigger. Like this you are going to analyze, right? Yes. So this is what the meaning, I can call it as comparator, meaning that when you are going to give two numbers as input, two binary numbers as input, it is going to produce the output as which one is bigger, or which one is smaller, or what is the other possibility, the given two numbers are equal, right? This is the meaning of comparators. So how can we do basically this in digital logic? So here basically we can able to compare two single bits, right? That is what I can call it as one bit comparator, right? So this is my requirement. For this requirement, you need to define the analyzation, right? Analyzation means what? When you are going to have two bits, one is A, another one is B, you are going to get 0 0 0 1 1 0 1 1 1 1, and you need to provide the solution for this one bit comparator. So guys, now try to observe, uh, when you are going to have 0 0 as input, meaning that both numbers are same. One number is 0, another number is 0, both numbers are same, right? So I can say that my result is 1, both are same, right? Similarly, when you are going to have 0 as one number and 1 as another number, uh, both are not same, I can say that 0. So I am not going to say here the bigger one right now, but I will try to say that those are not equal, so I am making it as 0. Similarly, when you are trying to say that 1 and 0 as input, so meaning that 1 is A and B is 0, and both are not equal, I can say, right? And when you are saying that 1 are the two inputs, I can say that both numbers are equal. Means here I'm trying to say that whether the given numbers are equal or not. Equal or not. Yes, if you are able to observe, the logic is like this, right? So if you are able to know, remember, this is a kind of expression AB plus A bar B bar, means it's a XNOR, right? So by the time of explanation, I have tell clearly XNOR is a kind of 2-bit comparator, right? Means if you are going to give two inputs, it will define whether they are equal or not, right? Now you have to define the solution along with whether they are equal or not. You have to define which one is bigger and it is smaller or not. Okay, fine. So how can we do that, right? So guys, if you are able to observe, so when you are going to get the possibility of A greater than B, so as you are going to have only single bits, you can directly define, right? When A is 0, B is 1, I can say that this is an invalid case, right? But when A is 1, B is 0, I can say that this is A greater than B. So the combination for this is, you can get as AB bar. AB bar. So when you are going to get this kind of situation, you need to produce the output circuit as 1. Similarly, you can able to identify, how can we say that whether A is less than B? See, one is A 0, another one is 1. So I can say that 0 less than 1, definitely. So the combination how we are going to get means this is A bar B. And what about the for equality? So you can simply use XOR gate it is going to define whether both numbers are equal or not. Okay, so now let's try to construct the circuit. So if I am going to have two inputs, a and b, first I will try to construct ab bar. So a is as usual, and I need to use AND gate. B bar requires NOT gate. So you are going to get here a B bar. Similarly, A bar B, right? So which is going to produce A bar B, and XNOR, I am going to take those inputs only, and I will try to use XNOR circuit directly, right? This is A XNOR B. Guys, now this circuit is meant for one bit comparison, meaning that one input is 0, assume, other input is 1, right? So you can define uh, like this, right? So whatever the output you are getting 1, that is the corresponding property. If I am going to give 0 and 1, here you are going to get 0, right? Here you are going to get 0. Guys, in the AND gate, if at least one input is 0, obviously your output is 0. So this is not the respective property for this 0 1. If you are able to observe, a will becomes here a, for a I have drawn here mistake. This should be a complement b, right? Yes. So when you are going to have 0 and 1, so here you will get 1, here you will get 1, right? When you are having 1 and 1, your output will be 1, meaning that this circuit is meant for a less than b. So this is activated. So when you are when the circuit, when at this point circuit is activated, which means that the first number is smaller than the second number, right? Like this you can able to check. So for this also it is going to be produced 0, right? So this is the circuit diagram for one bit comparator. One bit comparator, right? Guys, it is very simple one. So I haven't used any kind of K-maps like that, right? Okay. With help of basic thing we can able to write. Now we'll try to go with the next level, that is 2-bit comparator. Guys, in 2-bit comparator, you are going to have two inputs, one input having 2 bits, other input having 2 bits, right? If I am going to say that one number is a0 and a1, and another number is b0 b1, if you are going to assume, you are going to get around 16 combinations, guys, because each side requires 2 bits. So total in one particular row you are going to get 4 bits, right? If you are going to have 4 bits, how many possible combinations you are going to get? You are going to get 16 combinations, guys. Am I right? You are going to get 16 combinations. So these 16 combinations you need to analyze, and you have to define the circuit for it. Okay, so in simple way, I am trying to do, like for example, when you can say that, the given numbers are equal when a0 and b0 equal, and a1 b1 are equal. Am I right? See, this is 1 0 and 1 0 as given, right? a0 b0 are equal, and a1 b1 are equal. I can say that these two numbers are equal. If at least one number is not equal, then I can say that those two are not equal. Okay, guys, like how can we say that these two are equal or not, right? So by simply taking the circuit. So for example, I am trying to assume one as j1. So j1 means I am trying to construct a special circuit where this special circuit is going to define a1 and b1 are equal or not. I am trying to say a1 b1 are inputs, right? Now if I am going to give this input to the XNOR gate, if it is going to produce 1, I can say that the the A1 and B1 are equal. Similarly, if I am going to have A0, B0, and I can say this circuit as J0, right? If J0 is producing 1, I can say that A0, B0 equal. I can say that A0, B0 equal, right? But here my point is, I want to have I want to have to check whether these two bits and these two bits are completely equal or not. Then what I can do, I can simply take out the AND gate means if here now if you are going to get 1, I can say that the given two inputs are equal. If I got 0, I can say that the given two inputs are not equal. Yes guys, I hope you understood. Okay, fine. Now let's try to derive the case for whether, assume that this number is capital A and this number is capital B, whether the case is A is greater than B or not. Guys, what are the possibility to define when A is greater than B? You can able to assume A1, A0, B1, B0. One possible case is when A1 value is 1, when A1 value is 1 and B1 value is 0. B1 value is 0, and irrespective of A0 and B0, can I say that A is greater than B? Yes. So one possibility case is when A1 is greater than B1. When A1 is greater than B1. So I can say this case as A1 is greater than B1. So I can derive this as expression, as you know, A1 is 1 normal number, B1 is B1 bar. And is there another possibility? Yes. See, observe, when these two numbers are like A1 is also K, B1 is K, B1 K, then A0 must should be 1 and B0 must should be 0 to define this as A greater than B. A greater than B. Okay, fine. Now try to observe how can you write this expression. See, simply I am trying to write orally. So here A1 and B1 are equal. A1 and B1 are equal means I can say that as J1, right? Fine, J1. Now what about the case like it should be A0 should be greater than B0. A0 should be greater than B0, right? So you can write it as A1, A0, B0 bar. B0, right? For this combination only, your A greater than B is going to be followed. I hope you understood this one clearly, right? Yes. Fine. Similarly, what is the possibility for A less than B? If I am going to take clearly A1, A0, B1, B0, the possibility for A less than B, definitely one case is this is 0, this is 1. Irrespective of these two, I can directly say that A less than B. A less than B. So I can say it as A1 bar B1. And what is another case? These two may be equal. A1 B1 may be equal, but the case is A0 should be compulsory less than B0. So for this case, so to define A1 and B1 are equal, A1 B1 are equal, I have to take out J1. J1 should be A0 should be 0 and B0 should be 1. So this is the case for A less than B. A less than B, right? Yes. Now we can able to easily construct the circuit. So what we can do now? So this is for equal or not. Similarly for whether uh, whether A is greater than B or not. So for this what I did assume that I am trying to construct a different circuits here as A1, B1, A0 and B0. So first one is A1, this one is like this, A1, B1 bar. So you are going to get A1, B1 bar. This one is done. and this case is done. And what about this case? You are going to have J naught into A naught B naught bar, right? A naught, this is B naught bar, B naught bar, right? What about J1? J1 is a kind of, this is J1. See, you have to write it perfectly. Okay, so this is J1. So you are going to get J1 into A naught B naught bar. So here this circuit is meant for A greater than B. Okay, fine. Similarly, for A less than B, A less than B, you are going to have A1 bar, A1, B1, A naught, B naught. Uh, so A1 bar is, this is complement, and B1, B1, and J1. So J1 we got here, right? So I can take this as J1, and A naught bar, A naught bar, and I am going to get B naught. Finally, we are going to get. So this is the circuit for, they are saying that whether A less than B or not. Okay, I hope you understood this one, right? These two combinationally defines A greater than B. These two combinationally defines A less than B, and this is going to define equal. So means wherever you are going to get output as 1, that is the case, your expression is going to be true. Means equal, A greater than B or A less than B. Okay. The same case if you are going to extend, I can write it for 3-bit comparator. 3-bit comparator, right? Guys, when you are trying to say that 2-bit comparator, 2-bit comparator, you are going to simply take equality for A1 B1, sorry, A1 XNOR with B1, A1 XNOR with B1, and A naught XNOR with B naught, and XNOR with B naught, right? Means you are simply assuming J1 and J naught, J1 and J naught, right? Similarly, when you are trying to say that whether the three given bits of two binary numbers are equal or not, means I can assume that one as J2, another one as J1, another one as J0. Am I right? So if this is result is equivalent to 1, I can say that given numbers are equal. See, A0, A1, A2, B0, B1, B2. Now I am trying to apply for each and every combination of these equal, right? For A2 B2 comparison, I required one circuit J2. For A1 B1, I required one circuit J1. For A0 B0, I required one circuit J0, right? For all these, finally I am going to perform AND operation. So if it is equivalent to 1, I can say that the given numbers are equal, right? Similarly, for the another possibility, A greater than B, A greater than B. When you are saying that A greater than B possible or not, see, try to analyze. First case is, so you can make this as case 1 and make the another case as case 2. Here also case 1 and case 2, right? So whereas coming to here, whereas coming to A greater than B, you are going to get three cases more. One possibility is compulsory, A2 should be greater than B2. One is A2 should be greater than B2, or another case is A2 and B2 are equal, A2 and B2 are equal, along with this A1 is greater than B1. This is one case. Or another case is what? A2 is equal to B2, and A1 is equal to B1 and A1 sorry A0 is greater than B0. This is the case you can able to right. For this case you can able to directly write the expression. So for A2 is greater than B2, you can write it as A2 B2 bar, right? So this is 1, this is 0. Or the another possibility is you can get J2 J2. What about this case? A1 B0 bar. A1 B0 bar. So it should be A1 B1 bar. Or the possibility is J2 J1 and A0 B0 bar. Right? This is the corresponding expression for A greater than B or not. Similarly, I can define for A less than B. When you are trying to say that A less than B, definitely one possibility is directly I can define when A2 is less than B2, I can say that the number is A less than B. Or I can say that A2 is equal to B2 and A1 is less than B1, I can say that the number is less than. Or A2 is equal to B2 and A1 is also equal to B1 and A0 is less than B0. This case also you can able to define as A less than B. So you can write the case for this A2 bar B2, A2 bar B2 or J2 A1 B1 bar, or I can say A2 equal to B2, right? When say that A2 equal to B2, it should be J2 J1 and A0 bar and it should be B0. I hope I understood clearly, right? Similarly, you can write for any other case, right? So if I try to say 4-bit comparator, 4-bit comparator. So without any kind of like like analyzation, you can able to write for to check whether the given numbers are equal or not. You can write simply as J3, J2, J1, J0, right? So guys, you have to define what is J3. J3 is A3, B3 should be X XNOR. This is J3. Okay, fine. And the case for A greater than B, A greater than B, compulsory it should be like A3 B3 bar means A3 is greater than B3, or the another case is so J3 is equal, J3 is equal, then A2 is greater than B2, greater than B2, or the another case J3 and J2 are equal, A1 is greater than B1, or another case is J3 J2 J1 are equal and the possibility is A1 is greater than A0 is greater than B0. Right? This is the case. Similarly for A less than B, A less than B, you can directly say the most significant bits A3 is less than B3, or when A3 is equal to B3, I can say A2 is less than B2, or J3 and J2 are equal and A1 is less than B1, or J3 and J2 are equal and also J1 also equal, A naught is less than B naught. This is the case for A less than B. So for this you can able to construct the circuits easily as like this. Right? Yes. I hope you understood clearly. Thank you.